Hi General Maths students, in this video we're going to be finding the shortest distance between Rome and Melbourne. So you'll notice that both the latitudes and the longitudes of these positions are both different. So we're not travelling north to south or east to west, we're travelling diagonally across the globe, and this involves travelling on a great circle, which is the largest circle that could exist on the surface of the Earth. Now, great circles, we've actually worked with those before with the lines of longitude, and we use these formulas, or these formulae rather. If we were finding the distance in kilometres, we use this one, and for nautical miles we just multiply the angular separation by 60. B equals 60 times theta. So these great circles that we're referring to are just like lines of longitude, but they don't travel directly through the North and South Pole, they travel diagonally across the Earth's surface. That leads to the complicating factor that it's difficult to tell immediately what the angular separation, what theta is. And we need this formula here to do that. Now, this rearranges to theta equals the inverse cosine of everything that's over here. So we can go straight to this form of the equation, like this. And have the inverse cosine of all that stuff that is on the other side. Right? So that's the form I'll be using in this example. It's going straight to theta equals the inverse cosine of everything, not cosine theta equals. Righto, so what does all this mean? Well, lat P, lat Q, that's latitude P, latitude Q, and that just refers to the positions. So we could call Rome point P, which I'll colour code with green, and Melbourne can be point Q. It wouldn't matter if we did it the other way around, but this is fine. And the latitude at Melbourne, of course, is 38 degrees south, so that's going to go in these two spots. And the latitude at Rome is 43 north, so that's going to go here and here. The longitudinal difference, we work that out from the longitudes, the difference in longitudes for the two places. So that's going to go there. We'll work that out in a moment. Okay, so let's write down what we know about theta and do some substitutions. So theta is equal to the inverse cosine of the sine of, now I'll put these numbers in a moment. It is rather long, this formula. So look, this is just how it's got to be done. It's going to take a while to do. Righto. So the latitude at Rome is 43 degrees north. So I'll stick with that green colour. That's going to go here and here. And the latitude from Melbourne is 38 degrees south. So that's going to go here and here. Now we need to be careful because southerly latitudes need to be negative in this formula. So if you have a southerly latitude, make sure it's negative in this formula. Okay, the longitudinal difference. Let's work that out. Just do a little diagram to help us. There's 0 degrees there at the prime meridian. And Rome is 8 degrees to the east. And Melbourne is 145 degrees to the east. So the difference between those two is going to give us our longitudinal difference in there. So we'll subtract those. 145 take 8, which gives us 137 degrees. So just like if you were doing a regular one with finding the difference in longitudes if you're travelling on a line of latitude, say. Okay, so you might want to pause now and try putting this into the calculator, and then I'll show you a screen with the calculator on it. Okay, so here it is. I've typed it into the calculator. It's a big long one. And when you press enter, you get this 147.285. Okay, now that's probably rounded off to 3 decimal places. Look, we don't need to do any rounding off. This is what I recommend you do. At this point, you just write theta equals 147.285 ... We know it's going to go on, right? Now we don't need to DMS this angle like we usually would, because we're going to use this directly into the great circle formula. D equals 2 times pi times 6371 times, and our theta value is now that angular separation. ... I'm not even going to bother rounding it off. Okay, just going to put it in like that, because back on the calculator, I'm going to immediately tap multiply, and that carries that answer over without rounding it off. And then I'm going to multiply it by 2, by pi, and everything else you normally would. Divided by 360, and we see the distance in kilometres is 16,377.4. Okay guys, so these great circle formula questions are not too difficult, but entering the data into the calculator, entering the sum into the calculator is a little tedious, but you're just going to have to get used to it because it's the only way. So look in the description for the video, and let's try some of the questions.